Hope you people are doing good. So today we will be doing SDWAN Versa for the classes. Okay, and all of these classes are free of cost, what we are doing. And topic for today's class is SDWAN Versa, or I can say for the Versa Secure SD-WAN provisioning. So if I will give you the overview for this course is again named as VOBS, which stands for Versa Networks Onboarding Specialist. Okay. And it can be divided into mainly 6 parts. So the parts will be as SD-WAN, topology, and the site types. Second is we will be going to talk about templates. Third is we will be creating the device. So we can say device creation. Fourth is we will be going to talk how global ZTP, zero touch provisioning work. Or we will be going to talk about URL based zero touch provisioning. And we will also see script based zero touch provisioning. So these are the main topics of the course. And if you understand all of these topics free of cost, you can go over the Versa website and you can maybe, just crack the examination. For this examination, if I will talk about the prerequisite. So prerequisites are very simple. You should be aware about TCP/IP. And those who are working in networking, I hope you are already aware about these kind of protocol. Then you should be aware about what are the SD-WAN components. If you are okay with this, then it is really fine. If not, my previous playlist from the SD-WAN Versa, you can go and you can check what are the headends, what are the edge devices. Okay. Then basics of tunnels, how these MPLS tunnels, IPsec tunnels concepts work, you should be aware about it. Okay. And for sure, as I was mentioning, headend components in the SD-WAN Versa, you should be aware about the same. Or what I will say, you can check my pre-playlist series for Versa Essential. Okay, this is again available free of cost. You can use that for building up your concepts. So let's start with the very first topic or module. What we were talking about is SD-WAN topologies and site types. So if we talk about SD-WAN topologies, we can segregate the SD-WAN topology into 2 parts. 2 main parts, I will say. Okay. One is full mesh. Second is hub and spoke. Under this hub and spoke, again, we can divide it into 3 parts. First is spoke to hub. Second is spoke to spoke, but via hub. And the third is spoke to spoke, but this is direct. So this is a, maybe I will say, flow chart how your SD-WAN topologies can be divided, in which full mesh, what we are checking is the simplest form of your topology, where dynamic tunnels form in between each and every branch, and these tunnels are dynamic tunnels. So if I just created a simple topology, let us say this is my head end. Beneath are my branches. That is 100 of branches. Okay. Every branch will try to build the tunnel with each other. Okay. So that is simplest form of your hub and spoke. Now, this is your, this is full mesh. Then when we are talking about hub and spoke, that there is a little bit difference, okay? Because there are three main types in hub and spoke, and the very first type is spoke to hub only, right? So let us say this is my hub, this is my spoke, this is my spoke. These two sides are there, and for sure there is some transport. This is spoke 1, this is spoke 2, this is spoke 2, and this is my hub. So when I am talking about hub and spoke, and hub and spoke, the very first is hub to spoke. So, or spoke to hub, we can say, they will just communicate with hub. Okay, like that. They can just communication can be there with the hub only. So with the spoke to hub only topology, the remote site will build the tunnels only with your hub side. Okay, only routes will be advertised from the hub side. Tunnels will not build between spoke to spoke. No tunnel will form. I hope this part is clear. Then, if we talk about second topology, again, hub and spoke. But this second topology is spoke to spoke via hub. Now the difference is, if in earlier topology, those spokes cannot talk with even each other. But now if they need to communicate, they will go to the hub, and from hub, they can communicate with each other. Okay. Again, there is no direct communication in this variant as well. So with the spoke to spoke via hub topology, tunnels are again formed between the site and hub, but these tunnels will send the traffic, okay, re-advertise the LAN route from one spoke to the another spoke. But who will be the next hop? Next hop will be the hub side only. So communication is allowed over here, but that is forced to go via only hub. So these spokes cannot directly form the tunnels, but they can communicate with each other via hub. Okay, this is second form. Then let us talk about the third topology. And the third is the spoke to spoke direct. Okay. So when we are talking about spoke to spoke direct, do not get confused it with full mesh. Okay. Here, what we can create, when we are creating this kind of topology, you need to understand that we are creating some regional full mesh topology. Let us say this is your SDWAN in your organization, and it is segregated in complete around the world. So whole world is created. But just to segregate it further, I will create different region. Let us say this is my US region. Let us say this is my Africa region. Okay. then maybe Middle East, maybe APAC, whatever. I can create that those kind of region, Australia. Okay. Howsoever you wanted to design, it depend upon your designing team or your engineering team. Now, within these region, you can create full mesh. Okay, you can create full mesh, but within these regions, so within these regions, everything will be full mesh, and that is what is named as spoke to spoke direct. But if US need to send the traffic to EMEA, there can be hub and spoke again. Okay, so hub server, sorry, a hub device will act as a gateway between the regions. So hub can be used as a bridge between your different geographical region, or maybe you can say different organizational department wise you can do it. Okay, it's act as a transport domain in between different regions. So I hope this spoke to spoke direct is also clear to you guys. Now, very interesting when why we are creating these kind of topologies. So topologies, when we are creating or when you are just determining about the topologies in your SD-WAN solution, it in the background, it is controlled by your routing policies. Okay. And who is pushing these routing policies? For sure, you should be having controller. Okay. And if you have these branch, these all of where there is a branch, your controller will push all kind of policies, right? So this is your controller job to give the policies details under the BGP routing. Okay, it will give the updates what to do, what not to do. So in your Versa SD-WAN solution, site advertise their properties through the domain using MPBGP, right? We have talked about multi-protocol BGP in SD-WAN essential course. So you can just go and check from there as well how your BGP update contain the information about, let us say, site 1, site 2, site 3, site 4. Okay. And they will just see which transport domain a site is connected with. So if there are, for sure, there are LAN routes. Okay. So it will check which LAN routes need to be sent or not to be sent, depending upon the different topology. So key control, what you are using here is BGP communities, right? So using the BGP communities, site can tag the route, either they want to advertise or they want it to filter, depending upon your communities. If you guys are aware about RT values, which we are using in our legacy MPLS world, okay? Same case you can able to see over here also. So site will create tunnels between each other who are sharing a common transport domain, first of all. Okay, tunnel can be created only when the destination of the site is provided. And who will provide this routing, updates, or everything? It is BGP. So BGP will advertise site properties. And once these properties is available to one and another site, then your tunnel creation will happen automatically. You need not to do anything. And that is how your topologies comes into the picture. I hope regarding topologies, you don't have any question. If there is any question, you feel free to ask. So if you talk about SD-WAN site type, then we can segregate them into one of the three, stuff, which is your hub sites. It is large branches, maybe we can say. Okay. And the third one, we can say small branches. Okay. So as the name is saying, it is self-explanatory. Hub sites are those sites which maybe you can say at the edge of your data center or maybe your headquarters. Okay. So hub site is main site, maybe you can say, and usually we used to keep them as dual home, or we can say dual home or multi-home, whatever you want to say. Now, the case with your large branches is again very large sites or even headquarter sites. You can just make it as uh, large branches during your designing phase, because here also your extensive land deployment is there, and you can keep it as well as multi-home. Okay, maybe dual home I just said, but it can be more than two. So let us say dual home. Rather than dual home, we can say multi-home. When we are talking about small branches, it is like very few users or local LAN is limited, very lower bandwidth connectivity. Okay, not much. So it can be your single home or it can be your dual home, depending upon your environment, like depending upon your commercial appetite, I will say. Okay, so you can use one of the three site types. So very first, if we talk about hub site, okay, hub site is located into, as I told, in your data center. So for sure, when you are creating this, you should be taken into the consideration that there should be high availability deployment, right? Because your LAN will be a huge, and here can be a lot of service which can be running on maybe your next generation firewalls, maybe your load balancing services, and lot of services can be there depending upon your applications or depending upon, I will say, your business, what kind of business you are in. Okay, so that is your hub site. Let me maybe create a small diagram. So if I talk about hub site, okay, let us say there are my branches. Okay, these branches are just connected to my transport, underneath transport, and then this transport can be maybe MPLS, this can be INET, this can be anything. So from here, I should have a hub site. Okay, let us say this is my hub site. And in this hub site, let us say there are some firewalls services which are running upon. Okay, there are also some firewalls connected to, and then maybe there is some server form or whatever services you are running. There can be n number of services. So this is your bit like hub site, or you can say a DC. It should be your multi-home. Okay, like I am showing you two for the purpose of redundancy. You can say there are two routers, right? So hub sites are frequently data centers and are the first type that we need to discuss. And hub site normally should have high availability design, because you cannot take the risk of losing the main services, right? So to avoid that kind of risk, you should be taken into the consideration of high availability. And then during your LAN site, generally in your hub site, if we talk about this LAN part, there can be some dynamic routing in between your Versa device and in between your LAN. There can be some dynamic routing. Maybe you can run BGP in between your Versa device and your firewalls, okay? Or maybe OSPF, or who knows, whatever your project is, depending upon that. Services that are commonly deployed over here, as I told you, maybe it can be next generation firewalls, it can be UTM, Unified Threat Management, for sure, quality of service you need to provide. So here, configuration wise also, if I talk about, is little bit complex. Okay, so hub site is main site. Then second site can be large site. Large branches, or we can say headquarters site. Okay, there can be two names. I'm touching all the terms according to Versa syllabus for this certification. Okay, so everything what I am teaching over here, it is same what Versa documentation is providing. So here also you should not have anything any different. Again, there is a transport. There are some branch sites which are connected to your transport. Again, it can be your MPLS, it can be your internet or LTE or whatever. Okay. And for sure, here also you should have some redundancy. Again, I am just creating a single firewall, but there for sure there would be more. Okay. Not single. And then there should be some kind of LAN. So it is bit like equivalent to your hub site. Okay. And when we are talking about large branch sites, for sure, here the users, resources will be more, right? So large branch site, again, should have high availability because there can be LAN with respect to the LAN, with respect to the user, or you can provide the internet access over here maybe, okay? Who knows? So if there is some internet breakout, then for sure, you should have some kind of LBO solution from here, which your branch can use as a DBO solution from your hub site or maybe from your large branches sites. So services that are implemented over here are a bit like same as your hub site, not so much different. Okay. But as I am telling you, these all terms are from your certification. I am touching each and every term. Then it comes with your small branches. Okay. As the name is saying, these are very small branches, right? Very small. So small branches in the all topology, I created some small branches, which can be a single or dual home, very small number of users, no more services on the branches. But yes, you can have maybe direct internet access. Okay, let us say this is DIA, and you can do local breakout from here. Or if you don't want to use breakout from your side, you can use maybe your hub side or your large side as a DBO solution, distributed breakout, which means your internet traffic is going outside for accessing the internet connectivity. So that is your SD-WAN topologies and SD-WAN site types.